Okay, so we're going to create another file now for a class that's going to have the job of implementing the Markov chain algorithm. So we're going to click new file here, or file, new file, and we want just a standard Java class file. So Java class, click next, and we need to give this class a name, so we should follow the proper naming conventions. Pascal case, capital first letter. Let's call this, let's just call it Markov, the Markov class. I think that works. In the package, all right, that all looks good. And let's finish, and it'll give us basically an empty class file. We have nothing in the class right now. So this is where we're gonna put our attributes, those instance variables or class variables, and then the constructor, and then the any methods that we need. So what information does our Markov class need to store in order to do its job? So one thing is the input text that it's going to use to generate the output. So we're going to declare a variable for that. It's got to be private because it's an instance variable. And the data type is going to be a string. And let's call it input text. There we go. What else do we need? We need to know what the value of n is for the algorithm, how wide the sliding window is for when it's or the size of the prefix and suffix that it uses to generate the text. So that's gonna be a private int, and let's just call it n. We also want to store the size of the output, how many characters it should generate. So that's going to be an int as well, private int output size. And one last thing, thinking of the GUI little buttons and stuff that we put there. One thing is which mode we're in. If we're generating, doing the algorithm based off of individual letters or entire words. So let's do a bool makes sense for that, a boolean value, because it's either one of two options. So let's call it boolean letter mode. And so if letter mode is true, then obviously we're doing letters, and if letter mode is false, then we'll do the entire word. Okay, I think that's all the variables we need. We can always add more if we think of something later. Now, the next thing we would put when you're writing a class typically is the constructor. So let's declare the constructor here. Constructors need to be public so that you can access them to call them from outside the class. And it has to have the same name as the class, public Markov, parenthesis. And then we need to think what parameters we need when we create this Markov generator. So since we have these attributes here that need values, when we call the constructor, we would want to be able to pass these values into the constructor. So basically for each of these four attributes here, we're going to have a parameter in our constructor to allow us to pass it in when we create the object. So we'll declare a string for the input text, and an int for n, and an int for the output size, and a boolean for the letter mode option. Okay. And then that. All right, let me see if I get this to be on one line for you so you can see it better. Okay, there we go. Now, the code inside the constructor, its main job is just to assign values to these attributes. So the idea is after you've called the constructor, that this object has a complete set of values, that it's a fully formed object that's ready to do its job. So we just need to take the values from these parameters and assign them to the instance variables here, to the attributes. And what I've done is I've used the exact same name for these parameter variables as I did for the uh, attribute variables. So there can be some name confusion between the two. And what happens with Java when there's an attribute variable and a local or parameter variable with the same name, then there's what's called shadowing that happens. And Java will refer by default to the local variable or the parameter variable instead. So if I just put input text in this code here, it's going to refer to this parameter variable and not to the class variable up here. So to differentiate between the two, we can use the this keyword. So if we say this dot input text, it's now going to point to the attribute variable up here. And you notice that it turned green because there's a reference to it. It's being used now. These other ones are gray because they're not being used. And then I can assign to that attribute the parameter variable input text. So this one refers to this one. You can see the IDE highlights them for you. So when I put my cursor on this one, it highlights this one because it's referring to that. When I put my cursor on this one, it highlights this one up here because it's referring to that. Now another option other than using the this keyword is to not use the same name, is to use two different names. And that's typically, I think, what the AP exam does on its questions is it will use two different, like a variation, like it might abbreviate this one and call it like input txt, and then you don't have to use the this dot, and you just use the two different names to make them different, and then it automatically refers, right? So either one is fine. This dot n equals n, and this dot output size equals output size, and this dot letter mode equals letter mode. Okay. And that's all our constructor needs to do, is just give those initial values to the attributes. So now we can write the methods for this class. So these are the actions, the things that it can do. And our Markov class, we want it to be able to generate the text. So we're going to have a method. Let's make it public so it's accessible outside of the class. And since it's not a constructor, it's a regular method, we do need to indicate the return type. And if there isn't one, we would put void. But this one, we do want to have a return type because it's generating text. So we want it to return that text. So that data type is going to be string that it's going to return. And then we need a name for this method. It should describe what it does. So let's call it generate text. And I don't think it needs parameters since we're storing all the information we need in order to generate this text in our attribute class variables there. So we can just use those to do the job. Generate text, very good. All right, notice that it's not happy with this because we said we're going to return a string and we don't have a return statement yet. We're not actually returning anything. So we do need to actually return some string in order for it to not have a syntax error. Of course, we want it to actually generate the text and return that text. So eventually we'll fix that. All right, so how does this Markov algorithm work in order to generate its text? What it does is first starts with a random prefix from the input text, from the training text. So if we're in letter mode, then it's going to, and n is the size of that prefix. It's basically how many letters. So if n is 1, you're just going to do a single letter. So basically we just choose a random character from the input string. If n is 3, it's going to choose a random substring of length 3. And then it's going to search through the entire text to find every time that that same set of 3 characters or what single character, whatever it is, appears, and it's going to check to see what comes immediately after that with the same length. So the suffix would be the 3 characters that follow, and it's going to make a list of all of the possible suffixes for that particular prefix, and then it's going to randomly choose one, but it will weight the ones that appear more frequently higher so they're more likely to be chosen. And then it'll just slide over so that the new suffix that was just added to the output becomes the prefix, and it repeats the process, basically. So it's actually a very simple and straightforward algorithm, so it's kind of cool to see what kind of output it can generate. So we probably want to break this problem down into a few separate sub-algorithms, and we can write individual methods for each one, especially since we're doing, we want to implement both the letter mode and the entire word mode. So this generate text method probably should call one of 2 other methods, either generate the letter output or generate the word output, depending on the value of letter mode. And then we'll have methods for those. So let's just implement that real quick. Let's just do an if statement to check to see if we're in letter mode or not, and then call a helper method that we can write to generate each one of these different types of output. So if we're in letter mode, let's return the value that we get by calling generate letter text. Yeah, let's call it that. Okay. Else, if we're not in letter mode, then we're in word mode. We're going to return generate word text. Okay. And then we don't need this return statement down here because we've got these return statements. Okay. And of course, these methods are red because we haven't written them yet. So let's write those methods here really quick. So these ones, since these methods are only going to be called by this generate text method inside the same class, they can be private. They don't need to be accessed from outside the class. So let's make them private. It's going to return a string, and we've got generate letter text, and we've got private string generate word text. Okay. And so right now we're going to start by focusing on generating the letter text, writing that method. Okay, so we're going to probably want to declare some local variables here to implement this algorithm. We're going to need a variable to store the current prefix, the current 3-letter sequence, or whatever the value of n is. And that's going to be a string. So let's do that, string prefix. And we can go ahead and initialize it to that random choice of a prefix somewhere out of the entire input text, right, which is stored in our input text variable there. Good. And string prefix. Okay, so we're going to set that equal to, we're going to grab a substring out of that, input text dot substring. So we want to grab a random index from inside of that string to make sure that it's valid in order to do this. So let's generate a random index. Let's do that on a separate line so this line doesn't get super long. So let's do int rand index equals, and we'll use the method of generating a random integer that's used on the AP curriculum, so that you get used to that. We're going to call math.random, which generates a random double between 0 and 1, not inclusive. So we want to scale that up to the length of the string, the input text. So input text dot length. However, we're grabbing a substring of length n. So we want to make sure that the starting index isn't too close to the end of the string, because then our substring will go past the end, and that'll give us an out of bounds error. So we need to subtract from this length the value n. And then we can multiply by this random double between 0 and 1. But we do need to convert this down, round it down to an int to use as an index. So I'm going to put that all in parentheses. And then in front of that, we can put a cast to an int. And then, of course, we need a semicolon at the end. So now we should have a random, move this to another, actually, let me just do this, equals, well, you still can't see it, close enough. So that should give us a random index between 0 and n less than the length of the string, so that we can grab a valid substring of length n from it. So then our substring, we're going to start the substring at n, and then we want the length of this to be of the substring to be oh, sorry, not n. We're going to start it at the random index, rand index. But we want the length of the substring to be n, so we're going to stop it at random index plus n. So rand index plus n. There we go. Try to make this fit on one line. String prefix equals input text. Well, wait, that. Oh, the return statement. Yes, okay, I know we don't have a return statement. Let's just put a return statement in here so that it stops complaining. Okay. Are generating the random index for that prefix, and then we're grabbing that random prefix out of the input text to use as the initial prefix. And now we're going to repeatedly choose a random suffix for that prefix based on the distribution of those suffixes in the input text, and add that suffix onto our output text. And we want to do that in a loop so that we do that enough times to generate the amount of text that was requested that we generate. So we're going to need to declare a variable for what that chosen suffix is going to be. So let's go ahead and declare a string variable for that. String suffix. I don't have a value to give it yet, so we'll just declare the variable. And we need a string variable to store the generated text so that we can add to it as we're looping, and then at the end return that, that output text. So let's declare a variable for that, string output text. And that is what we're going to return. So let's go ahead and fix our return statement here, so that instead of just returning some random string, we return our output text. Okay. And so here we are going to loop until we've generated enough text. So we can use a for loop for that. And the syntax for a for loop, we need to declare a loop variable to count the loops, basically, the index of the loops. So we're going to declare an int variable. I is really common for that. And we want to start looping at 0. And then we need a semicolon, and then we're going to put the expression that will evaluate to see if it should continue looping. So this is basically how many times we're going to loop. And we are asked to generate output size characters, letters, and we're doing it in groups of n, right? So we're going to do, if n is 2, we're doing 2 at a time. If n is 5, we're doing 5 at a time. So the number of times we need to loop is output size divided by n, approximately, which is close enough. So we're going to continue to loop as long as I is less than output size divided by n. And then another semicolon, and here is the increment expression, and we just want to count up by 1 each time, so I plus plus. And then curly braces, and we have our loop. So inside of here, we're going to choose the suffix that we're going to add onto our output text.
Are we gonna already have an amount of characters like on the output text from when we chose our prefix?
Yeah, that's the first thing we want to do is add the prefix, the initial random prefix to the output text. And if we do that at the beginning of the loop, then when we choose a suffix and then kind of shift over so that that suffix becomes the prefix, then it can, at the top of the loop again, it can be added, that new one can be added to the output. So yeah, I would start with output text plus equals prefix. So each time the prefix gets added to the output text. Oh, and we do need to initialize output text with an empty string before we can start adding onto it. Otherwise, it's null. When you declare a reference type variable without assigning a value, it gives it a value of null, and so you can't concatenate a string onto null. So we have to actually create a string object, which you could do by calling the string constructor like that, or you could assign it an empty string like that. And there's a slight difference between the two that we'll learn about later, but we just need to assign it an empty string. Okay. So we're adding the prefix, and now we need to choose a random suffix based on the distribution of those. So I think this would be a good place to do another helper method that is going to scan through the input text to find all of the possible suffixes that we could choose from, and then we can just choose one of those. So we'll call that method to get that list of possibilities, and then we'll choose one of those randomly. So since there's going to be multiple possibilities, we need some list type variable to store all the different possibilities, and I think an array list would be a good choice for that. So let's declare a variable that is of type array list, capital A, capital L. And array list uses what's called a generic. So you can have this array list can store any reference data type in it. And you need to specify using these pointy brackets what the data type is for this particular list. And for us, it's going to be string, since we're doing sections of text. And we want to give it a name. So let's call it suffixes, plural. And we're going to fill it with the return of this helper method that we're going to write. So we'll call the method something like get suffixes. And this get suffixes method that we're going to write needs to know what the prefix is that it should be searching for to accumulate the list of possible suffixes. So let's give it the prefix as the argument there for the parameter. And of course, a couple things we got to do here. Using array list, you have to import array list in order to use it. We can click the little light bulb here in NetBeans and choose the suggestion to add import for Java util array list, which will write this line of code up here for us. And get suffixes doesn't exist yet, so we're going to need to write that method. Let's go ahead and put a private, and it's going to return an array list. That's its return type, array list of string as the return type, and it's called get suffixes. And its parameter is of type string, which is the prefix. Okay, so we'll have to write this method, probably do that next week. But let's see, we got a few minutes, so let's assume that this method has done its job and returned to us a list of all the possible suffixes. And so this list will contain multiple copies of the same suffix if it appears more than once in the input text. So we can just randomly choose one of them with an equal probability for each one individually. But since there's multiple copies of the more frequent ones, then they're more likely to be chosen automatically because there's more copies of it. So we don't have to worry about like choosing a random value and distributing the probability. It'll automatically do that for us. Um, so we just need to choose a random index out of this list. So let's do that. Int um, random. Let's see. We already have random index. I guess we can. Let's do random uh, list index, something like that. Okay, and we're going to use that same sort of formula, math.random, multiply it by the length of the list. So that's suffixes, but this is an array list. So instead of dot length, it's dot size. Oh, I had to be different, but it is. And then we just need to cast that down to an int. So put parentheses around it and an int cast there. Okay. So now that we have this random list index, we can use it to grab the random suffix. So we can take suffix and have it equal to suffixes dot get random list index. Okay. And now that we have the suffix, we want to change the prefix to become this suffix that we chose. So prefix equals suffix. And then when the loop repeats and goes back up to the top, the output text will add that prefix onto itself. And yeah, random list index, spell those the same, rand list index. There we go. And I guess looks like we didn't really even need a separate variable for the suffix. We could have just assigned prefix here. But yeah, I think that's fine. Makes sense what we're doing. Kind of shows you how the algorithm works. Okay, so it'd be good to test what we have so far and see if it's working. But we're getting out of running short on time, so I think we're going to stop here today. And then next time we'll test this with some test data, just make sure that it's doing what we expect it to do, and then we'll write this get suffixes method that is needed by this. And then we also still need to put code into the GUI so that it makes use of this in order to use the information from the GUI and display the result on the GUI. So we'll work on all that next time.